that at t equal to 0, this is the initial current that we have. So you guys remember that the behavior of the current in an RL circuit, it's going to be exponential. It tries to reach a final value. It takes approximately 5 time constant to reach that final value, but it just basically, you see here, it's increasing, but as soon as it hits this point, the voltage changes. So now it starts decreasing. And again, it starts increasing, decreasing, and this would continue. Okay. So you can again see that we're gonna have different quadrants here. You see that current can be negative, voltage positive, and what we discussed about the reason to have anti-polar diodes. So this is what I wanted to show you. Now look at this current. Is this sinusoidal? It's not sinusoidal, right? It looks like it. It's not that much sinusoidal though, especially that like we're not using what we're gonna see later, PWM. So here like we have a lot of harmonics, but you see like it mimics like going up and down and going up and down. It has a fundamental frequency in it, but it has a lot of harmonics. Okay, so this is what I wanted to mention. And again, I wanna emphasize on this one that we have bipolar modulation. And basically here, we create signal for S1, and that signal, the inverse of that, or like we have a NOT gate here, that would be S4. But you see that like we only switch between these two states, right? So S1, when S1 is on, also S2 is on, right? So here we have S1 and S2, and here, or like we fire them, okay? They might not be conducting, their diodes might be conducting, but we fire both of them at the same time, okay? So the same thing here, this is gonna be S4 and S3. Okay, you guys remember that like to have the MOSFETs or IGBTs conduct the voltage, we have to provide a gate signal, a gate voltage, right? So like we're applying the gate voltage for S1 and S2. Here we're applying it for S4 and S3, S1, S2, S3, and S4. Okay, so this is basically what we do, and I'm gonna talk about this one, like the comparator that you've seen before, and we're going to talk about how we create these gating signals or gating voltages, right? Like so, IG and so on. So that's about bipolar modulation, right? We only go between negative VDC to positive VDC and then back to negative VDC, and this would continue. Now we have another modulation, which I think you can guess what it is. It's called unipolar modulation, that actually switches between all these 4 states. It's not just these 2, right? So then we can't say like S1 gate signal is always the same as S2, because you see that like here and here are different. So we would need to have 2 different comparators, one to create the gate signal for S1 and S4, one for S3 and S2. Okay, so in this case, if I want to draw the voltage the output voltage, it would look like this. And it would continue. Okay, so here, let's start from here. Here, this is positive VDC, this is negative VDC. Right, so here we have S1 on and S3 off. So let me write down 1, 0. Right, so here like S1 is on, so it means that S4 is off, and here S3 is off, so it means that S2 is on. Okay, so we are here. Right, at this point we get to a point that's 1 and 1. Right here, the voltage is 0. What does that mean? This means that both S1 and S3 are on. So it means that S2 and S4 are off. Right? S1 and S3 are on, so it means that the current goes through this loop, this upper loop. Right? We have 0 voltage. And then at this point we would have 0, 1. It means that S1 is off, S3 is on, so it means that S4 is on and S2 is off. And finally we would have 0, 0, which means that S1 and S4, S1 and S3 are off, and it means that S4 and S2 are on. So again, these two now are on, so this is like how we would have the current. I'm sorry, this is the other way around. Okay, so now let's draw the current similar to what we did for the bipolar modulation. Let's do it for unipolar modulation. So the reason this is called unipolar, because the changes in output voltage is only the level of the voltage that we have. It goes from negative VDC to 0, and then from 0 to VDC. The jumps between the voltages is the amount of voltage that we have at our DC source, right? But you remember, for bipolar modulation, the jumps are like 2 times the voltage source that we have, the DC voltage source that we have. Now, if we draw the current here, for a load similar to what we had before. Now, what has